In this video, I will show you how to model this pipe in SolidWorks using this mechanical drawing that is on the right side of this screen, and I will also show you how to use SolidWorks flow simulation for simulating the flow of water inside this pipe and getting some results from that simulation. So first, I'm going to close this ready model. I'm going to stop the animation and close this model. Now we're going to start a new model. So I'm going to click on New and click on Part. Now we will go back to this split screen mode, and first I'm going to go and click on Features, and here we can see that the mechanical drawing on the right side of the screen. So here we can use a swift boss. So to make this body of this pipe. So to use the swift boss, we need two sketches. The first one is the profile. The second one is the path that the profile will follow to make this pipe. So first we're going to go to sketch, and we will sketch on the, let's say, right plane. So this sketch will represent the profile for this pipe. So I'm going to sketch a circle here, and if I just maximize this window a little bit. So here I'm going to give this circle a dimension of. So to know the dimension of this circle, I'm going to zoom in on this mechanical drawing and go to the top plane or top view of this mechanical drawing. So here we can see on the right side of the screen that we have 97 millimeters. So this is going to be the diameter of this circle. And we have here an opening for this pipe, which is on the top view of this mechanical drawing, which is 65. I can draw it here, but I'll show another way to make this hole inside this pipe. But first we're gonna finish this body of this pipe. So the first sketch is ready. I'm gonna go to the next one, which is the front plane here. I'm gonna sketch on it. So this next sketch will represent the profile that the path for this profile to follow to make this pipe. So I'm gonna make two lines here. First one is a horizontal line. The next one is gonna be the vertical line. Now the dimension of these two lines, the first one, if we can look at this mechanical drawing, here we have 145 millimeters. So I'm gonna type it. It's going to be the horizontal line, and this one's going to be the vertical line, which has here 175 millimeters. Now the two lines are ready. Now we need to make a fillet. So I'm going to go to fillet and click on this angle, and here we have a fillet. We can look at this sketch. We have here a radius of 90 millimeters. I'm going to type it. Now our fillet is ready, and so the path. Now all we have to do is go back to the features. Now our swift boss is activated. Now if I hover on these two options, here we can see that we have here a profile, and here we have a path. So the profile is going to be this circle, so I'm going to click on the sketch, and the path is going to be this sketch. Now we have the body of this pipe, and if you cannot see this preview, you can go down to options and click on show preview. Now the script is ready. Now the next step is to make this hole inside this pipe. So this is gonna be the passage that the water is gonna go inside through. Now if I'm gonna show two ways to make this passage. So the first way is to make a swept cut, but here we need also two sketches. I'm gonna sketch this cut, the the profile for it, and here I'm gonna sketch a circle, and this circle has a diameter of, let's see here, as I said, 65 millimeters. Now if I exit the sketch, now the profile is ready. For the path, I'm going to use the same path as we did with this swept one. So I'm going to go to swept cut and click on the circle that I made. And for the path, I'm going to go to this design tree and go to swept one. And I'm going to use the path, which is sketch 2. Now we can see the preview of this cut inside this pipe. Now if I just click OK, now we have this pipe. Now another way to do the same thing, which is a little bit easier, is first I'm gonna suppress this swept cut, and I'm gonna modify this sketch a little bit. So here, instead of one circle, I'm gonna make two, and this second circle is gonna be 65 millimeters, which is which represent the opening for this cut. So if I exit the sketch, we can see that we get the same results. So which one you are going to use is up to you, since the two ways lead to the same result. Now this is the modeling of the pipe itself, pipe body actually. Now we need to make two flanges, which is this one and this one, the top and the right side flanges. So I'm going to start with the top one. I'm going to click on this face and choose sketch. Now here we have in this mechanical drawing, I'm going to make a circle here, and I'm going to give it a dimension of 225 millimeters. I'm going to sketch a circle, give it a dimension of 225 millimeters. Now we also need this opening, which is this one. So instead of making a new circle, I'm going to go and click on convert entities, and I'm going to convert this edge to a circle on this new sketch. Now I don't have to worry about the dimension and making a new circle, so this is a shortcut for doing that. Now I'm going to exit the sketch, and now I'm going to go to extruded boss and choose this sketch. Now we can see that the opening is not active yet. So I'm going to go to select contours and get rid of this sketch. Now here we can click on this circle and also this circle, and we have the right version of our sketch. So I'm going to click OK. Now we have the body of this flange, but we have also to decide what's the depth of this extruded boss. So here the depth is 25 millimeters. You can see that in this mechanical drawing. So I'm going to type it 25 millimeters. So now we have our first flange, but we need those holes that represent the bolts holes. So I'm going to click on this face, and I'm gonna make a circle. So this circle represents this circle that's here. So this circle is, let's say, is the placeholder for the center of these circles. So I'm gonna make this circle. I'm gonna give it a dimension of 185 millimeters, and I'm gonna first I'm gonna click on this circle and click on this construction geometry. That means that this circle is not going to be included in this extruded cut or extruded pass later when we make a hole inside this flange. So here I'm going to draw a circle, and here the circle is we have 8 of them here. If we can look at this mechanical drawing, the top view, and the diameter of the circle is 20.5 millimeters. So I'm going to give it this dimension. Now it's ready. I'm going to exit the sketch and go to extrude cut to cut this, make this hole. So the depth here is 25 millimeters, which is the same depth as this flange. So I'm going to type it and click OK. Now another way to do the same thing is to go to this direction 1 and choose this edit end condition, and here we can say up to surface. That means I want this cut to go to, for example, this surface, and now it will cut through all this flange without giving the dimension that will go through. Now our cut is ready. All we have to do is just repeat it, and for that I'm going to use this circular pattern, and I'm going to click on it. Now to do this, I'm going to need a direction and number of instances, and also the features that I want to repeat. For the direction, I'm going to use the center of this circle. So to do that, you can just click on this edge or this edge. It's up to you. Now the number of instances is declared here on this mechanical drawing. Here we have 8 instances, so it's here 8 instances. Here we have, if I hover on it, the angle that this this pattern will go and be this circle. So 360 degrees will cover the whole surface of this flange. Now for the features, I can just go to our model and click on this cut, and now we can see a preview for this repetition. If you don't see a preview, you can click on this partial preview from this options. So, or another way to do it is just clear this features and go to this design tree and click on this cut, and we get the same result. Now our first flange is ready. Now we're going to go to the right side flange. If I can move our mechanical drawing a little bit to the left, you can see that this is the right view, and you can see here the flange, which is the same, which has the same dimensions as the first one. So I'm gonna click on this face and go to let's go to extruded boss and do the same steps as we did with the first one. also have the same thickness. Now I'm gonna make a sketch for the cut. I'm gonna exit the sketch and I will go to extruded cut, and we will cut it to a depth of 25 millimeters. Now we're gonna repeat this cut. We'll do the same steps as we did with the first one. First flange, I'm gonna click on features and choose this feature. Now our two flanges are ready. All we have to do is just to make this extra pipe extension, which is on the right side, or on the left side of this pipe. We can see it here. It's just a small pipe. And to do this, I'm going to use a reference. So this reference is going to be plane. So I'm going to click on this arrow and choose reference geometry and choose plane. Now the first reference is going to be this face of this flange. Now the distance that we're going to give this plane from this face of the flange is going to be this distance. You can see it on the right side of the screen. The mechanical drawing, which is the top view here, it says 240 millimeters. I'm going to type it, and when I click, we can see that it goes to the opposite direction. To rectify that, I'm going to click on flip offset, and I'm going to click OK. Now all I have to do is just right click on this plane and click on sketch, or I'm gonna go to extruded path and choose this plane. And I click on this direction X to choose the right direction. Now here I'm gonna draw a circle, and this circle has a diameter of 50 millimeters. You can see that here on this mechanical drawing. So I'm gonna draw a circle, and it's gonna be in the middle. And I give it a dimension of 50 millimeters, and now it's ready. I'm going to exit the sketch. Now we need to choose the direction. Here we have blind. That means if I just know the depth, then I can type it here. Now, but we will go to up to surface. That means I want to extrude this. Extrude the sketch until it reaches a certain surface. So I want it to reach this surface. So I'm gonna click on it. Now we can see that it has reached this surface, and the model looks okay. I'm gonna click on check, and I'm gonna hide this plane since I don't need it. So I'm gonna click on this face of this pipe, and I'll sketch a circle. And this circle is a small passage inside this pipe, and this has a depth of here it says uh, 28 millimeters and a diameter of 24 millimeters. I'm gonna draw a circle of 24 millimeters. Exit the sketch, go to extrude cut, and the depth is gonna be 28 millimeters. I click on OK. Now we have a small cut inside this pipe. Now we have another passage which is a smaller one than the first one, and this has a diameter of 20 millimeters. So I'm gonna click on the space that is inside this small pipe and choose extrude cut, and here I'm gonna draw another circle, and this has a diameter of, let's say here, 20 millimeters. And this cut is gonna go through all this pipe, so I'm gonna choose through all as the direction of this cut. Now we can see that it has reached the other side of this pipe. Now if I can make a section view to see if this one is identical to the mechanical drawing that we have here. So I'm going to click OK. I'm going to click on the Z-axis, and we can see that we have the same result, or the same result as I said, as this mechanical drawing. You can change the display style. So I'm going to go to hidden lines visible. So now we can see that we have the same result. So now the first part of this video is ready. So we have modeled this pipe. All what we have left to do is just to make a flow simulation. To do the flow simulation in SolidWorks, first we have to enable the flow simulation. So I'm gonna maximize this window and go to SolidWorks add-ins and click on this tab, and here we can see the SolidWorks flow simulation. So click on this button and you will enable the flow simulation. It is here, we can see it, it has this tab, it says flow simulation. So I'm gonna click on it, and before doing any flow simulation, we have first we have to check the geometry. So I'm gonna click on this button, check geometry, and here we have some options. The first category here is analysis type. So here we can click on internal analysis or external analysis. So here I'm going to click on internal, and here for the options, here we have improved geometry handling, create solid body assembly, create fluid body assembly. So first I'm going to click on check to see if this model is valid for this flow simulation. And here we have the results and the status. It says here failed, no water tight model. Analysis type is internal, the fluid volume is 0. So now this analysis tells us that this model is not ready for the flow simulation. The reason is that we have the fluid volume 0. Now, SolidWorks doesn't know what's the size or the volume of this fluid that will go inside this pipe. So, to fix this, we have to add, go to Tools and click on Lids. And those lids, they will encapsulate this pipe so that SolidWorks will make, if I just cancel this, so SolidWorks will make a computational domain, so it can calculate the flow of water inside it. And as I said, to do that, we will go to Tools, Create Sleds, and we're gonna click on the faces that we want to close. We have to close the openings for the flow that will go inside this pipe. I'm gonna click on this face and also this face. Now here we can also control the thickness of these slits if we want by clicking on this button to adjust the thickness, but I'm gonna leave it as it is. I'm gonna click on OK. Now we have this pipe closed. Its openings have been closed. Now, if we go to check geometry again and we click on the type of analysis to be internal and we click on check, now the result is successful. Geometry is okay. Now we have the fluid volume and the solid volume. And we have, as I said, other options here. We can create a fluid body and solid body. So if you're gonna make a fluid simulation and another software, let's say like ANSYS, then maybe this option is important, like this creates fluid body assembly. If I click on check again, now we're gonna have, if I minimize this, we're gonna have the volume of this fluid that will go inside this pipe. And from here we can extract this, let's say this volume of this model to ANSYS and start making flow simulation if we want. So I'm gonna close this, and we have other options here. So go back, and we can see here we can click on this show fluid volume. We want to see the volume inside this pipe. We can see it here. So this is the volume of our fluid, and it was not affected by those holes of the bolts. So now the geometry is okay and the model is okay. Now we're gonna go to the wizard to start our to set up our flow simulation. First, we have here a project. Here we can type the project name if we want to write some comments here also. And here we have a configuration to add to the project. We can use the current, or there are some options here you can choose from. I'm gonna leave it as current. Gonna click on next. Now here we have unit system. Here I'm gonna choose SI units, and those are the SI units. You can see them here displayed. And if you want to create your own units, then you click on this checkbox. I'm gonna click on next. Now here we have the analysis type, and here I'm gonna it's by default fluid flow, which is okay. And we have another thing here that we need for this simulation, which is gravity. Now we can see that gravity is on the z-axis, and we can see that it is represented by this arrow, which goes in the wrong direction. We need it to be in the opposite direction of the y-axis. I'm gonna type this to be 0. Delete the minus. And here I'm gonna type minus 9.81. When I do that and click, we can see that we have the arrow here displayed that shows us the direction of this gravity. Uh, Now here we have those options for geometry handling, and here we have the analysis type. It's set to be external. Now this is not right for our flow simulation. For this model, I'm going to set it to be internal and leave the rest of these options as they are, since this is only entry-level flow simulation. And I click on next. Here we can determine or select the type of fluid that will go inside the spine. Here we have gases, liquids, and the list goes on here. So I'm going to click on liquids and choose water. And here we have to click on add to add this fluid to our project fluids. Now here we have the flow characteristics. Here we have the flow type. Here it is laminar and turbulent, and this is good. Since we don't know, we haven't calculated the Reynolds number, which determines the flow type to be either laminar or turbulent. So I'm gonna move on. Click on next. Here we have wall conditions. Here we have the parameter, which is default wall thermal condition, which is here is adiabatic, if I pronounce it right, adiabatic wall. And that means that this wall is idle, so it doesn't transfer heat. And since we are not interested on thermal conduction, so I'm going to leave it as adiabatic wall. Here we can decide the roughness, and I'm going to leave it as 0, so it means that we don't have any roughness inside this wall, inside the wall of this pipe. I'm going to click on next, and here we have the initial conditions. We have pressure and temperature and velocity here. I'm going to leave it as it is and click on finish. Now it has taken some time because now it has calculated the computational domain for this float simulation. And we can see this computational domain represented by this box here, which has black lines here. So this is the computational domain. We have some options. So this is the name of our project, which is project 1. If we want to adjust the settings that we have seen earlier, all we have to do is just right click on projects and on input data, and here we can change the general settings if we want, as you can see here. Now we have to set some boundary conditions here and some goals, and then we will start our flow simulation. So I'm gonna click on this section view so we can select our boundary condition easier. So I'm gonna click on right click on this boundary condition and insert one. And here we have some options. We have the space to apply the boundary condition, and here we have reference axis. Here we have the type, So we have flow openings, pressure openings, and wall condition. So I'm gonna click on this button, which is flow openings. So that means I'm gonna use some openings to set some boundary condition. So I'm gonna go to inlet volume flow rate, flow, and click on it, and I'm gonna select this face, the inner face for this sled, for this face, so that means that the water will start flowing uh, from this opening. Now here we have the flow parameters. I'm going to set it to be half cubic meters per second, and here we have normal to phase, which is the case. We have spiral, and here we have 3D vector. So here I'm gonna leave it as ununiform, and I'm gonna click on fully developed. That means that when it comes from this opening, that this is gonna be the flow rate is gonna be half cubic meters per second. Now this first boundary condition is ready. I'm gonna click OK, and now we're gonna set two boundary conditions that for the exit of this uh, flow rate of water. So I'm gonna right click on this boundary conditions, and here for the outlet for this flow rate, I'm gonna click on this button, which is pressure openings. Here I'm gonna click on environment pressure, and I'm gonna click on this face, the inner face of this opening, and we can see that those are the conditions for temperature and pressure. I'm gonna click OK. You can see this the pressure is represented by those arrows that goes both ways in the x direction or x-axis. So I'm going to add another one here, same thing as we did the previous one. I'm going to click on this other opening, click OK. Now it's ready. Now we can just run the calculation, okay, but I'm gonna set some goals, and here I'm gonna set some surface goals. So for example, I want to know the static pressure, the average static pressure, total pressure, and dynamic pressure in this at this opening. So if you are wondering why there are three pressures, so static pressure has to do with the pressure itself. Total pressure is the addition of static pressure and dynamic pressure. Dynamic pressure has to do with the velocity or the flow rate of this water that will go inside this pipe. So I'm going to click on OK. Now this is those are the goals for this inlet opening. And right click and insert some another surface goals. And here I want to know the mass flow rate, volume flow rate, and this opening. You can add another for the other exit. So here I want to know the mass flow rate, volume flow rate, and this opening. Now, since this flow simulation is simple, I'm not gonna adjust the global mesh. So here we can adjust the global mesh and tweak these options, but I'm gonna leave it as, and leave those options as they are. And here the result, we can see that there's a note here that they are not loaded. That means the flow simulation is not hasn't run yet. So to run this flow simulation that we have set, all we have to do is just go to this button and click on Run. Now here we're gonna see some options here, and here we have no calculation. That's good. And cores and memory usage. I'm gonna run on this computer. I'm gonna use this computer, and I'm gonna use all the CPU cores for this simulation. So the result processing after finish the calculation. Here we can load the results after doing so. I'm gonna click on this option. We have to click on this one if it wasn't clicked or checked. I'm gonna click on Run. Now the flow simulation will start, and we have this window. Now we can see some notes here, and those are the goals that we have set earlier, and we can see their progress displayed here, and here we have the calculation, and we can see the iterations here. Um, Now it has finished, and it has loaded the results. So we click on this result part, we can see we can now view the results. So here we have cut plots. I'm gonna right click on it and click on insert. Now it's gonna choose the front plane by default since we made a section view. And that's good. Here you can see the type of how you want to display the results. Here we have contours. I'm gonna leave it as contours, and here you can see the pressure if we want, or other parameters. I'm gonna leave it as pressure. Here we have a number of levels. I'm gonna leave it as 10 levels of color variation here. I'm gonna click OK. Now we can see the pressure inside this pipe. So we can see this the variation here. We have 10 of them, and here we have reduction in. You can see that we have reduction in pressure, and this is the pressure variation across the pipe. We have also here some drop, pressure drop here, and some increase here at this place, this area. Now this is the first cut plot. We want to hide it to set another one. We can do that. All we have to do is just right click on it and click on hide. I'm gonna right click again and insert a new one. And this time I want to know the velocity. I'm gonna click velocity and click on. Now we can see that the velocity here is maximum at this area, and it's gonna decrease at this area and this area as well. Now to avoid that, we can, feather this angle, so it will that will, enhance the flow of water inside the small pipe. I'm gonna hide this cut plot as well. Now we have another thing here, which is very helpful, is the flow trajectories. So this will give us an animation for the flow inside this pipe. So I'm gonna right click this option and click on insert, and here we have those options. So the first one here, we have to choose a plane, face, or edge. So this option is for where the flow will start flowing inside this pipe. So I'm gonna click on this inner face of this opening, and here we have number of points. I'm gonna set it to be 200 points that will go through this pipe, and now we can here we have draw trajectories as we can set it the flow to be as arrows, pipes, lines with arrows, spheres. We have some options here. I'm going to click on lines with arrows. Here we have some options, arrow size, line width, and here we have velocity. So here we can, for example, we can view the velocity, pressure, or temperature. So I'm going to view the velocity here in this flow trajectory. I'm going to click on OK. Now, the more you add those number of points, it will take longer. So now all we have to do is just right click on this flow trajectory one that we have made and click on play to see how the flow will go inside this pipe. We can view how the flow will go inside this pipe. I can zoom in, we can see that flow is represented, the velocity is represented by arrows, lines with arrows here. We can change the view type here. First, I'm gonna stop this animation, and we can edit this, the definition. We can add it as, for example, spheres, and I'm gonna click on OK. Now we can see the flow as spheres. If I play this animation again, can view how the flow will go inside the pipe. Now this is for velocity. You can see how the velocity will vary inside this pipe. I'm gonna stop this animation and I'm gonna hide it. I'm gonna add a new one for the pressure, and here I'm gonna set it to be at 200, and the type's gonna be arrow line with arrows, and here I want to know the pressure. Now we can see that so this is for pressure. I'm gonna animate this one. Now we can see how this will go inside this pipe. And we can see the variation of pressure represented by this chart. And here is the flow trajectory too, which is playing right now. I'm going to stop it. And so now we have modeled this pipe and we have also made a flow simulation for it. So this is the end of this video. I hope that you have enjoyed it, and I will see you in the next one. Thanks for watching.